astonishing images from NASA of what looks like Ceres, but it's on Earth. With its dark, heavily cratered surface interrupting tantalizing bright spots, Ceres may not remind you of home planet Earth at first glance. This dwarf planet Ceres, which orbits the Sun in the vast asteroid belt between Mars and Jupiter, is also far smaller than Earth in both mass and diameter. With its frigid temperature and lack of atmosphere, we're pretty sure Ceres cannot support life as we know it. But these two bodies, Ceres and Earth, formed from similar materials in our solar system, and after combing through thousands of images from NASA's Dawn spacecraft, which has been orbiting Ceres since 2015, scientists have spotted many features on Ceres that look like formations they've seen on Earth. By looking at similar features on different bodies, what scientists call analogies, we can learn more about the origins and evolution of these bodies over time. You can check out these features on Ceres, see if you recognize any on Earth. Doesn't this look like a height, a volcanic dome snowed over? This is on Ceres. Crater on Ceres, central bright area called Carelia Facula. This is it. I wonder what that white stuff is on the top. On Ceres, Occator crater, as dawn approaches Ceres early 2015, two mysterious gleaming beacons stood out in images, the bright spots of Occator crater. When the spacecraft spiraled into orbits closer to Ceres, high-resolution images reveal that there are not just two spots, but many. The center of Occator contains a bright 2,000-foot high, that's 500-meter high dome, called the Carelia Dome. This is it right here. That's one of the many bright spots, which is covered with bright material. The bright material on top of the dome is called the Carelia Facula. A collection of smaller bright regions called Vinalia Facula is clustered on the eastern side of the crater floor. Thanks to Dawn's observations, scientists think the bright material is made of sodium carbonate and mineral salts. Also, Dawn scientists think the Carelia Dome formed from briny liquid or mushy ice rising from below the surface, what we call hydrothermal activity, because it involves heat and thermal, that is, heat and hydro, water. Scientists have two theories about how this hydrothermal activity happened. Either the heat from the impact that formed the crater caused briny liquid or mushy ice to push up on the surface so much that it popped out, or alternatively that the heat from the impact could have enhanced activity related to pre-existing liquid reservoirs below the surface. This is a similar structure that we find in Canada. Isn't that something? I never thought Canada had volcanic domes, but it does. Example of a Pingo in Canada. On Earth, Pingos. There's another one. When groundwater on Earth freezes, it can push up against the overlying soil, creating a dome-like structure called Pingo. These structures appear near the Arctic regions of Earth, including Canada's Pingo National Landmark. The dimension, shape, and fractures top of a Pingo resemble the Carelia Dome on Ceres, which may have formed from alternating cycles of ice punching up and diffusing into the surface of Ceres. This is what Lee Nay Quick, planetary scientist at Smithsonian Institute National Air and Space Museum in Washington, explains. And this is one here, Panum crater in the Sierra Nevada mountains in California, for example. And that's huge. When you look at the size of the roads, this is huge. Created from what they think is frozen water pinching up. All right, that's their theory. And on Earth, we have volcanic domes. Panum crater on the foot of the Sierra Nevada mountains of California has rounded edges and fractures, summits that remind scientists of the Carelia Dome as well on Ceres. Both the Panum Dome and the Carelia Dome sit inside pits. Lassen Peak in California, which is a lava dome, also has a similar shape, as does the dome in the Mount St. Helens caldera in Washington State. This is the Sierra Lakes, California. You can see how the frozen water that has been pushed to the outside looks. Now this is, if anybody knows, please let me know, because we see this for this type of a geometric formation on mountains even in the area of the Sinai Peninsula. I don't know how this is formed, but look at that. This is so geometric. Look at this. Look at this. Look at this. Look at this. And one of my viewers yesterday commented to me. He said it's not erosion, it's electromagnetism. And for the life of me, I don't know what he meant by that. I asked him to explain. He didn't get back to me yet. Maybe he'll see my comment today. What is this? They're as if they're carved out. Look at this. They're so geometric. They're almost perpendicular to each other. These V marks. I'm going to make a video on the shapes of the mountain tops and mountain sides in the whole of the Mount Sinai Peninsula, especially around Mount Sinai, where of course we know that the prophet are Saint Moses, the Moses of the Exodus, received the Ten Commandments on Mount Sinai, and all the rocks there, the stones and the mountain sides, have this very strange appearance, carved out like this. Anyway, that's just going off on a tangent. So we see this also in the Sierra Nevada, and it's very close to the crater as well, as you can see. What is that? Very strange. We still have a lot of things to learn. On Earth we have Searles Lake. Now a lake like Occator crater, Searles Lake in California, Mojave Desert, is famous for bright evaporite materials, that is, materials that remain long after the evaporation of the salt water. Once the lake fed by water from the Sierra Nevada mountains, today Searles is a dried up lake bed with white mineral deposits. Mining operations collect minerals rich in sodium and potassium for industrial use. These minerals are mostly found in subsurface brines that are pumped to the surface. And this is an image of Ceres, Lonely Mountain, shown with a vertical exaggeration factor of 2. Look at that, isn't that something? Yeah, amazing images. Ceres Ahuna Mons sticks out on Ceres as a tall, lonely mountain with bright material dusting its slope. Similar to the material found on Occator, the bright coating is made of sodium carbonate. The leading hypothesis is that Ahuna Mons is a cryovolcano, very cold volcano that has erupted with salty water. So the volcano also brings up the salty cold water. You see, isn't that something? Mud and volatile materials instead of molten rock. Ahuna Mons rises an average of 2.5 miles. That's 4 kilometers above the surface surrounds. About the same as the height of the summit of Mount Rainier in Washington State. Here we go. Ahuna Mons does not appear to be associated with any impacts, suggesting Ceres might have had cryovolcanic activity in the recent past. Okay, this is a dome in Iceland. Hildarfjall Dome in Iceland. And of course we know that all their heating comes from geothermal there. That's fantastic. They have as much heat as they need. On Earth, the Hildarfjall Dome in Iceland, this is it. While nothing in the solar system is exactly like Ahuna Mons, the Hildarfjall Dome in Iceland has a similar shape. Both have loose, fine-grained material, are similar in their proportion of height and widths, and these mountains are very different in composition. The Icelandic Dome, and this is the Ceres Dome, Icelandic Dome. The Icelandic Dome formed by silicate volcanic material, whereas Ahuna Mons formed primarily from water and salt, with a minor contribution from silicate materials. Despite the chemical differences, however, the materials on Earth and Ceres behave similarly when they protrude out of the crust from the volcano. This is what Ottaviano Rusch, the research scientist at the European Space Agency in the Netherlands, explains. And this is the Chaten Dome in Chile. It's a lava dome. Basalt lava. On Earth, the Chaten Dome in Chile, another volcanic structure reminiscent of the Ahuna Mons, is the Chaten Dome in Chile, this one here, located within a caldera. The cauldron-like volcanic features. Beyond Earth, the Compton-Belkovich volcanic complex on the Moon contains a dome that seems to have formed by silicate materials erupting. This means that silicic dome formation is a process not limited to Earth, Rusch says. So this is the Moon, of course. I don't see any domes. I see craters. Where are the domes? There are no domes, there are craters. And what's more, what are these very strange lines? As if something has dug in, scraped in, and moved along. The same thing here, dug in and moved along. And this is very strange, it's totally square. I don't see any domes, I see only craters. Alright. On Ceres, Samhain Katane pit chains. I know I'm not pronouncing it right, but I'm doing my best. Ceres is full of craters, large and small, but it also has chains of small bowl shapes or elliptical pits that did not result from impacts. Pit chains such as Samhain Katane are caused by fractures or faults in the subsurface which formed up to 1 billion years ago, and when the fractures or faults leave behind empty space under the surface, loose materials falls in from above, forming the pits on the surface. This is Ceres. Yeah, this is Ceres, not the Moon. Maybe I'm just... okay, this is Earth, of course. Okay, that is Ceres. Okay, they say that this is material that has fallen in. Alright, that's how they explain it. They've blocked out some things here, I don't know why. Same thing here, maybe it's just a glitch. And this is Earth. Pit chains in northern Iceland, just north of the Krafia volcano. Where are the pit chains? This doesn't look at all like Ceres. At all. These are roads, of course. Okay. And this again is Ceres. Northern Iceland has a system of pit chains related to faults and fractures. Scientists believe these pit chains formed because of the seismic events in the 1970s. As the 2000, this is what they're talking about. As a 2011 study led by David Farrell on Southwest Research Institute San Antonio finds that the pits resulted from poorly consolidated material falling down into the subterranean cavities, which were produced by faults and fractures. It's possible that stresses derived from material upwelling from deeper within Ceres resulted in parts of the crust being pulled apart, which may have formed from Samhain Katane. Alright, and this is Ceres, of course. Holani crater on Ceres. That's a crater, and it looks like something came spurting out and spreading all over the area. On Ceres, the Holani crater is, what do we see here? 21 miles in diameter, with sharp rims and bright materials, one of the youngest craters on Ceres. Some flow features are associated with a mountainous ridge in the center, while other flow features run outward from the crater's rim towards the surrounding area. Pitted terrain on the crater's floor and northern rim probably formed when an impacting body caused water under the surface, which had been locked in Ceres crust, to vaporize. That's why pitted terrain is additional evidence for water ice as a key component of the crust. Pitted terrain, here we go. Pits here. Okay, pits here. But that is huge. That's another crater there. Okay. And what is this? You will be surprised which country this is. And that is a crater. That is a crater. And these, of course, are just, okay, it's a city, a farming area around it. The country is Germany. Rees crater in Germany. Isn't that something? Okay, I didn't know Germany had volcanoes. Rees crater in southern Germany has formed from an impacting meteorite. Okay, it's a meteorite impact. There you go. It's my mistake, sorry. Meteorite impact in Germany about 15 million years ago. That must have been huge. Okay. Is an example of a rampart crater, a crater whose material flowed down to the presence of volatile materials such as water when the meteorite hit. So it was a meteorite Earth impact that took place in Germany 15 million years ago. Okay. Although Ceres does not have craters that are exactly rampart in nature, some of the craters in Ceres, such as the Holani, do have flow features in their ejecta blankets, layers of rocks that were overturned and deposited around the crater as during the impact event, as we can see here. Look at that. Rees also has clusters of pipe-like structures in the bedrock that are the basis for our understanding of the formation of pitted materials on Mars, Vesta, and Ceres. Landslides on Ceres. Okay, and we have a landslide here. Mud Creek landslide in California. That's huge. That is, it cut the road. It cut the ocean road. It's huge, huge. And of course, there's no way they can. What are they going to do? Cut through that again? It's just going to keep sliding down. The whole mountainside's coming down. Forget that road. Forget that. It's cut off. Dawn has revealed many landslides on Ceres, which have shaped the presence of water ice, which have been shaped by water ice. Images show 3 different kinds of landslides on Ceres. Left is the Gannon crater, hosts an example of a type 1 landslide, which is relatively round and large and has thick deposits or toes at its ends. Type 2 and type 3 features are shown in the middle right of the image respectively. Scientists think type 1 landslides form in areas where the ground is rich in ice, which may occur near Ceres' poles. Type 2 landslides are often thinner and longer than type 1, and type 3 landslides form in ice-rich ejected material from impacts. This one here. And here we have this in California. On Earth, landslides can occur anywhere on Earth where the ground along the slopes becomes unstable, such as last year's landslide north in California. A hillside called Mud Creek collapsed in May of 2017 after the area had received substantial rainfall, increasing the amount of the groundwater in the area. The way the rock and dirt slid down over Highway 1 into the ocean resembles the way the mixture of ice and rock skidded down Gannon crater on Ceres. In some cases, water or ice in the ground can increase the likeliness of landslide occurrence. The Dawn mission is managed by JPL for NASA's Science Mission Directorate in Washington. Dawn is the project for the Directorate's Discovery Program, managed by NASA's Marshall Space Center. I'll leave links below for you for this on NASA. Kindly support by contributing to my Patreon account. You'll find it in the description box below. Thank you.